So welcome everyone to what I'll call mini metabesity. This is a scaled down version of an annual conference and truly a medical movement founded by our good friends at Kinexum. I'm David Fox from our FDA Pharma and Biotech Practice Group. I want to welcome our guests from Kinexum, both here and on the phone, who've organized this truly great event. As regulatory lawyers, we get to work with lots of outstanding regulatory consultants, but in my view, there's none better than the friends and colleagues we have at Kinexum. Truly we collaborate on numerous projects, and we would be lost many times without you. With me today at the table, Alexander Fleming, Zan Fleming. Zan and I go back many, many years to our FDA days together. Zan, as you'll see, is truly one of the most thoughtful people in the field. And Thomas Seoh, who's now the CEO of Kinexum. Zan was the founder. And Thomas is the closest thing I think I'll come to a true Renaissance thinker today. And hopefully that will come through today as well. I just also want to give a special thanks to Catalina Castro for organizing this event. There's tons of work. I'm pretty helpless in doing this, so I really leaned on you quite a bit. Thank you. And then to my co-host, Phil Katz, who will be giving us closing remarks. We'll proceed for about an hour with presentations by Thomas and Zan, and then our call-in video, perhaps, guests, Dr. Nir Barzilai and Joseph Cook, until about noon, 12:15, and then time for Q&A. To briefly set the stage, I went back and I looked at FDA approvals 20 years ago, 1999, when FDA approved about 40 new drugs, and the list was quite informative. It was mostly type 2 diabetes drugs, osteoarthritis drugs, drugs for weight loss, drugs for insomnia, sleep aid drugs, and drugs for GI upset, GERD drugs. About 20% of the drugs in 1999 were for small or orphan populations, and only about 10%, just about three drugs at a time, were for oncology. So very, very interesting profile. Now, if we fast forward to today, or I said, just to go back for a moment, I think what that reflected, which was really the ethos of the industry in the 1990s, was let's treat as many people as we can for as long as we can. Now, if we go to today, in 2018, FDA approved 60 new drugs, or 59 to be precise. 60% of those drugs were orphan drugs, and 1 out of every 3 was an oncology drug, so triple the historical levels, a complete shift. The remaining groups were infectious disease, which is a good thing because we have a serious problem with drug-resistant bacteria. So infectious disease, and then neurology. 0 drugs out of metabolic and endocrine. 0 drugs for preventive health. 0 drugs for any of these larger, sweeping public health issues that really drive healthcare costs. So quite stunning. But we at Hogan, we're about being ahead of the pack and looking at trends before they actually coalesce. And I think we are on the front edge of a new trend. I think that regulators and policymakers and hopefully people in the industry have figured out that the orphanization of drug development, while it's been very profitable and very productive for patients, is not the end of drug development. It's one facet. And so we've talked about in these programs gene editing. We've talked about immuno-oncology. In our last program, Lynn and I talked about CBD, cannabidiol, and drugs made from botanical sources. And I think all of those areas, they're here to stay. But I do think the pendulum may start to be oscillating. And I think there's a lot of attention now that's building around drugs for the large populations, these just large sweeping public health issues that, as I say, really probably drive healthcare costs more than anything. And so that's what this program is about. And I'm going to get out of the way and turn it over to my friends Thomas and Zan.
Thank you, Dave, very much for your very warm welcome and your kind words. For the record, for people who may not be familiar with us, Kinexum is a strategic advisory firm providing guidance on regulatory, clinical, CMC, and other translational aspects of life science product development. Kinexum founder and executive chairman, G. Alexander Zan Fleming, MD, trained as a diabetologist and endocrinologist at Emory, Vanderbilt, and NIH, and spent much of the 1990s at the FDA Division of Metabolic and Endocrine Products, where he was deeply involved in the approval of the first statin, human insulin analog, metformin, PPAR agonist, growth hormone for non-GH deficiency conditions, and other contributions to the pharmacopoeia. Zan, I'm passing you the mic.
Well, thank you so much, David and Phil. What an honor to be here. You have been comrades in arms as we have gone against or up for different issues, let's say. And you are tremendous teachers. We have learned so much from our association over the many years, not only with you, but many of you here in the room and in the firm far and wide. What a great opportunity to talk about something that is not pie in the sky. I want to emphasize that, and I hope that you'll leave convinced that Hogan has a role in making this real. So more about that in a moment. In effect, what we're going to do today is make the elevator pitch, presenting two of the key components and what will be required to get us towards the goal of real products that could prevent chronic disease. And we're not just talking about drugs. In fact, drugs may be the more minor contributors to the solutions. We're talking about digital technology, other approaches that may involve anything ranging from social media to reorganizing how we build cities, how we deal with loneliness. These drive what we're talking about, the underlying metabolic roots of chronic disease. Let me try to explain. As you know, for many decades, we've been targeting these conventional indications or therapeutic targets. And we've done some good at it. And as David has pointed out, we've really picked up steam in the oncology area, and that's a good thing. And we've made a lot of progress with cardiovascular disease and to some extent diabetes and obesity. We've started to target dementia. We don't really have any particularly effective products for that indication, but it's a crying need. And even aging is starting to be targeted, but we're far from having any approved indications for that related therapeutic area. These have all been targeted independently, out of silos of experts, out of silos of regulatory reviewers, and so forth. What we want to propose today is that there is a constellation of chronic diseases that are pathogenetically connected and actually have common metabolic roots that in part, and admittedly just in part, but in part do drive the risk of these components of what we call metabesity. Metabesity is a condition that can be targeted in a very practical way, and you'll hear in a moment about a very important first step that Nir Barzilai is taking in the design of a trial with an already approved drug that has prospects for moving the needle against this particular constellation of diseases. So metabesity, in a few words, is simply the major health problems that we're facing that Dave alluded to, and recognizing that they're all driven by underlying metabolic, commonly shared roots, which can be targeted, and that's the key point. Let's begin with the end in mind, because I want you, again, to accept that this is not pie in the sky. What we're talking about is taking a drug like one that is the first-line therapy for diabetes, glucophage or metformin, and adding an indication like this, indicated for reducing the risk of major age-related diseases. The trial that Nir Barzilai will be talking about could be the means of supporting this indication. That's how close we are. Not to say that this trial won't take a while, but you'll hear more details about that in a moment. We could have an indication that ultimately uses the word health span. That might become an accepted word for regulatory purposes. We're not there yet, but it's starting to gain currency in the field of disease prevention. I'd like you to think ahead to what would be a role that Hogan could have in developing an act that sort of is analogous to the Orphan Drug Act, which was passed back in 1983. And this essentially would be one to provide comparable incentives to industry, and again, industry here is broad, not just pharmaceutical companies, but one that would facilitate, would incentivize the development of treatments for not only preventing chronic disease, but for approaches that can reduce the rate of aging. And these are intertwined, and you'll get a greater appreciation of that in just a moment. So this could be done soon. It doesn't have to wait for the data to come in. We already have enough evidence to suggest that this is an actionable legislation, and perhaps we'll be pursuing that in subsequent days with Dave's help. So we begin now, and I'd like to have Dr. Nir Barzilai, who is a preeminent scientist, medical scientist in the field of aging, and he's also a multifaceted person. He's a TED talker. He also was on the Entebbe raid back when he was in the Israeli army. So he is a force to be reckoned with. He's a comrade in arms for sure, and we are delighted to have him from New York City. So Nir, we thank you, and we look forward to your presentation.
Well, thanks for the introduction. I want to tell David and Thomas and Zan that when I watched the Super Bowl, I really realized as an aging expert that old Belichick wisdom beat up the 33-year-old young innovative coach. When we're talking about aging and defeating aging, we hope not to defeat the wisdom that you have. So thank you very much. And it's not that I'm calling you old, by the way. I just see young people in the audience. So what I'm going to tell you today is that you, of course, know that aging has biology, because you kind of can figure out who's...
Excuse me, Nir, I'm sorry, we're having a little trouble listening. Could you maybe move close to the mic and speak up?
Is this better?
A little bit, just close to the mic.
Okay. What I'm going to tell you today, that aging has a biology, but more important, that this biology can be targeted. Aging can be delayed, it can be maybe prevented, and maybe even reversed. And there's lots of preclinical studies and even data from humans that support it. So I'll go fast over some of those things. What you see in this slide is the relationship between death from diseases, variety of diseases, and age. And please notice that the y-axis is a log x. So when you look at heart disease in blue, you see that the rate of death from heart disease goes from 5 to 5,000, which really means that aging is the major risk for heart disease. Cholesterol is a threefold risk for heart disease. Aging is really an overwhelming risk. you see that the story for cancer is the same, and for diabetes is the same, as for Alzheimer is the same, and there are kind of parallel lines that suggest that they have common mechanism. So when I came to this field of aging, I said, wow, if aging is the common risk, if aging drives the diseases, then our only hope is to target aging. Because any success that you'll have with a single disease will mean that you're just going to get the other disease. So we're not going to make this much of a progress. So, you know, when you walk into the emergency room with a heart attack and you get a stent or a bypass, this is a local treatment to your heart. It doesn't really address the aging problem. If you can bring the next line. No, back, just the next line. Back, please. Yes. You can argue that, hey, we know that those diseases have genetic roots, and you would be right, but those genetic roots still needs aging in order to come out. So, in other words, if your mother is diabetic and you're obese, the first disease that you might get is diabetes. And the second disease can be something else, but this is only going to determine which disease appears first, and not the fact that aging is the major risk factor beyond it. Next slide. I want to show this slide just for you to realize one thing. We can measure aging and its biology on a cellular level. We can look at the sperm and determine if it comes from a 70-year-old person, a man. We can look at an egg and see if it comes from a 50-year-old woman. But when fertilization occurs and the blastocyst comes out, they erase the age of the sperm and the egg, and it starts at 0. We don't accumulate the age of our parents. So we figured out to do that, and I'll tell you there are two companies that are spending a lot of efforts in trying to really make it relevant to human aging, but you can understand that from our perspective, aging should be reversed and not only targeted, delayed, or prevented. Next slide. Now, we scientists agreed on pillars of aging. And the pillars of aging are here, and I'm not going to talk about each one of them, but about their connectivity. And the connectivity is important because we know that we can target each one of them and get effects on the others. So, for example, if you look at proteostasis, there is a process called autophagy, which is the garbage disposal of our body, that in our cells in our body to get rid of proteins and other garbage. If you can increase the autophagy and clear garbage, there is effect on metabolism also, and there is effect on stem cell and inflammation. So we would like to have targets for all of those, but any progress will really be important. And to summarize numerous studies that were done, I could tell you that health span, and not only lifespan, but health span, which is the most important thing, has been extended in numerous animal models, by the way, models like nematodes and flies and mice and rats and monkeys, by genetic ways, by interaction with the environment, by drugs. And actually, some of those drugs are in human domain, but haven't been used to target aging specifically, so I'll talk more about that. Next slide. The National Institute of Aging has an intervention testing program where anyone can suggest an existing drug to test in 3 different centers if it delays aging. Now, in each one of those examples, you see the control animals that start dying usually after 600 days, and you see a second line that shifts to the right, and those are the interventions that have extended lifespan and not shown here health span. One important point to note, if you see the rapamycin on the bottom in the middle, the intervention started late at life and still extended health span and lifespan. It's really not never late to target aging, even though not all the effects are similar. Some drugs are actually better when you're old, and some are not as good. Also, you can notice on the right that combination of 2 of the drugs, rapamycin and metformin, extended lifespan the most in the intervention testing program by more than 24%. All to tell you that there are drugs that could be repurposed probably that are in existence already. Not all of them are really safe for chronic use yet. Next slide. From a human perspective, you know that biological age and chronological age are not the same. You can see it in your friends or in your parents or in their friends. And one of the ways for me to tackle this problem is recruiting people like you see here. This is 4 siblings with a picture on the right. Sometimes in the 1920s, they were born somewhere between 1910 and 1920. And on the left, in the same position, 90 years later, and what's important to note that all of them reached over the age of 102. In fact, the sister on the left lived to 110, and the brothers died at 107 and 109. What are the chances that 4 siblings in New York City will get to this old age? And by the way, the woman standing on the left, Helen, who died at 110, she smoked most of her life 2 packs of cigarettes. So it's not only that they lived long; they were resistant to a lot of the environment that we know is not good for the rest of us. Go on, but next slide. But really, the point here is that the first thing that we looked was to see, are those guys getting sick when all of us getting sick and then they live sick for most of their life, or is their health span and lifespan goes together? And what you see here is the combination of 2 studies. One is the New England centenarians and one is our study. Our study in green and blue, the green are our controls that don't have longevity, and the blue is our centenarians. And what you're seeing is how many have a disease-free survival, and the diseases are listed above the graph. And you can see in the green that the controls after age of 60 have increased accumulation of diseases, and only 10% of them at age 80 don't have any of those diseases. While the centenarians have an extended life health span of about 20, 30 years. And even after the age of 100, 30% of them don't have any disease. Some of them just die one day in their sleep. But the most interesting thing about them is that they have a contraction of morbidity. It's not only that they live healthy and live longer, they are sick less at the end of their lives. And it's interesting that the CDC has been looking since 1993, those data is from 93, on the medical costs in the last 2 years of life of somebody who dies over 100 to those who dies at 70, and it's a third of the cost. This led people to write about what we call the longevity dividend, the fact that increasing health span even moderately is going to contribute trillions of dollars to the economy. And at this stage, we cannot not do it really. is a huge economical impact on staying healthy. Next slide. Well, the challenge is that, the challenge is that for most diseases, there's biological discovery, biotech, drug targeting. They want then, for hypertension or cholesterol, right? They want other mechanisms. They want to improve the drugs. They want to have more business. It's good for the scientists. The problem with aging is that the FDA doesn't recognize aging or something like aging as a target. And of course, then the healthcare provider don't have to pay the clients, and the pharmaceuticals are not going to jump into what the biotechs are developing because there's no really clear business plan. And this is what we scientists at the field decided to look at and come with a strategy. Next slide. And the strategy is around repurposing a generic, cheap, safe drug that's called metformin. Many of you know this drug. And the blue on the bottom is those pillars of aging that I introduced to you before. And I'm not going over the mechanism of action of metformin, but just for you to note that metformin is targeting every one of those pillars. And it's not that I really think that it directly targets any of those pillars, but metformin fixes aging. We know it does it on the cellular level. We know that animals that get metformin are healthier, they live longer. And some of the things we are monitoring is just the effects of a cell that was before old becoming young again. So I'm not saying that metformin really targets everyone, but at the end, you see the associations and the connection, and that's why we chose metformin. Next slide. Beside that, metformin has substantial effects on health span. In intervention studies, so clinical studies, metformin already had amazing and significant results. For example, it delays diabetes or prevent diabetes in type 2 diabetics, a 30% effect. Metformin delays cardiovascular in people with diabetes, also 30% effect. There's huge amount of people of studies that shows that people on metformin have less cancers. There's support for the fact, and more studies actually, that shows that metformin can delay early cognitive MCI and Alzheimer, even in non-type 2 diabetics. And I'll show you two other studies to suggest that metformin is really a good tool for us to come to the FDA and say, you don't need to read about this drug. You have everything about metformin, but we would like to repurpose it. Next slide. This is an example of association of metformin and variety of cancers. And this is something important that we actually convinced the NCI, and their new director is really coming from the from the studies of aging, Ned Sharpless. But at the NCI, they used to view every disease as a different disease. Every cancer is a different cancer. But still, aging is the major risk for those diseases, so that we showed them that actually you could see effect on most of the cancers because it's the aging part. It's not the genetic or the specific disease part. So there are more than 200 studies now registered and funded by the NCI to look at the effects of metformin on cancer. Next slide. And I think this is the most compelling study we have, first of all, it's with 200,000 people. It couldn't have been done in the United States because, and it was done in the UK because there you can go into the pharmacies and look at people and the drugs that they are using. And in this example, they looked at 12,000 people that were prescribed sulfonylurea, which is another anti-diabetic drug. And they controlled them with 12,000 people in red that didn't have diabetes, but they were treated in the same pharmacy, same doctors with some of the same initial health issues. And you see that people with diabetes, as we know, had higher mortality after 5 years. But then they looked at 78,000 people who were on metformin, controlling them in black with 78,000 people without diabetes in the same pharmacies. And you see that metformin had 17% less mortality. Now remember, the people on metformin had diabetes, which the others did not. They were more obese to start with. They had more diseases to start with, and still they have an increase in longevity or a decrease in mortality. Just to bring it home again that some of the studies specifically have been done, and the mortality study have been done to suggest that we have enough preliminary data to say that metformin delays aging. Next slide. So the trial that we're doing is called TAME, Targeting Aging with Metformin, and it's going to be the first proof of concept that show that a composite of age-related disease can be prevented by metformin. But as I said before, for me, the major interest, and for us scientists, the major interest to negotiate with the FDA and to get a new indication that will be like aging. By the way, we don't want to call it aging because not everybody who's old has diseases and there's ageism, but we actually agreed on a wording of an indication that is really preventing a composite that prevents multimorbidities of aging. Next slide. Just to tell you kind of the hard part to understand in our study is that we don't care what disease you bring with you to the study, and we don't care which disease is the outcome. Because for us, it's about aging. We don't know which disease you'll have first, but it is what it is, and the second disease is what it is because of your aging, and not because of the disease specificity. And this is shown here in the graph, and you could look at men, women is kind of the same, they have less rates. But if you take somebody who has a cognitive deficit and you ask, what's the chances that he'll get CVD, cancer, death? It's similar to a guy who has cancer already, and what's the chances that he'll get the other diseases, or somebody who has cardiovascular disease that will get the other diseases. It's kind of the same because we're monitoring aging. And for that reason, we don't need to have a significant result to any of those outcomes. In fact, if we had a significant result in our clinical trial, then the study would be stopped. Because, you know, if you prevented cardiovascular disease, you should have everybody on metformin. But we actually want to show that the composite is changed, as exemplified in the next slide. So what we're planning to do is to take people between the ages 65 and 80 that are not totally healthy. They either already walk slowly or had an age-related disease. And all we need is 3,000 of those because the rates of any one of those events is very high. Unlike if you wanted only diabetes, which you'll need probably 12,000 people for this study. And in a double-blind placebo-controlled trial, our primary outcome or the FDA outcome is the time to incidence of any major related disease that are stated here. We do hope also to obtain secondary outcomes that are more of the functional, disability, aging outcomes, and also biological outcomes that will help us to establish biomarkers of aging that changes with treatment. Next slide. So while the rate of comorbidities increases after the age of 60, I mean, people get one disease in the treatment and a second disease in the treatment, and all the treatments have side effects, so now you have 3 diseases and 3 treatments that probably are also interacting with each other. This cannot go on. We have to tackle aging and start and flatten this acceleration in comorbidity. Next slide. So to summarize, aging has a biology that can be targeted. There are strategies to translate it to clinical trial. We hope that TAME will change the regulatory challenge. I should say that Zan and Tom are advising American Federation of Aging Research, which is leading the trial in dealing with the FDA. If you want to see our meeting with the FDA, Ron Howard did a great film for National Geographic about age of aging, and there you can see our interaction with the FDA and an interview with the FDA. There are lots of biotech and pharmaceuticals that are already developing drugs and are waiting for the regulation to happen. Last slide. So this is what we're talking about. If we could have more time in the bottle, I could spend more time with you. Thank you very much.
Nir, thank you so much for that. We'll definitely take questions at the end of this session. We'll now go on to, let me introduce Joe Cook Jr. He's had a couple decades career at Eli Lilly, where he became Group VP Global Operations. Then he retired before beginning a series of subsequent careers, including Chairman and CEO of Amylin Pharmaceuticals, which he turned around to engineer a 10-figure exit to AstraZeneca after introducing 3 diabetes drugs to the market. Then co-founder and chairman of Ironwood Pharmaceuticals, which grew into another 10-figure company. He is currently, among other things, co-founder and principal at venture capital firm Mountain Group Capital. Joe, I'm passing the mic over to you.
Participant lines unmuted.
Okay, can you hear me now?
Yes, thank you.
Oh, okay, good. So it's a pleasure to speak to you and to also follow Nir. I have great admiration for the work he's doing, and I think I'm going to try to establish a case to go alongside his comments that we cannot wait. Now is the time. As Zan often has said, the patients are waiting. And what we are developing at a company that I'm involved with called Nusert Biopharma is a disruptive approach to obesity. And we believe that this is an alternative model to targeting metabesity. As Zan correctly identified early on, the traditional model of developing human pharmaceuticals has largely resulted from a reductionist mindset. Reduce the problem down to the lowest and smallest amount of contributing factors. Hopefully you can get to a single cause and effect, treat the cause, and observe the effect. And for many diseases, that's appropriate. But I want to make an argument that the diseases associated with excess energy and lack of activity are really not simple single cause and effect relationships. In fact, they're far greater than that. So next slide, please. The obesity market is staggering. I don't need to tell you these, but just to put a point under it, underscore, prevalence in the United States is probably approaching 100 million U.S. adults today. But what's frightening is the childhood obesity prevalence of 19%. These individuals will not live full and productive lives. And more importantly, they will suffer from the consequences of disease comorbidities, and I'll explain a little bit more about that in a minute, that will essentially accelerate the ages. You refer back to Nir's column showing when comorbidities occur. With this kind of childhood obesity, those individuals are going to have a curve that starts trending upward with comorbidity much earlier in their life. That's going to drive cost. And it's more importantly, it's going to drive a quality of life down. What's really interesting about this is that the U.S. medical cost of obesity is approximately $1,500 a year per person. And yet somehow we don't really view obesity in the same light as cancer or a heart attack. It's sort of accepted as maybe a part of our normative values. And as a result of that, the last point on the slide, studies show that 46% of adults who are obese and meet the criteria, there are 46% of those, but only 2% receive medicines. Next slide, please. Is this a problem that's at a static level, or are we continuing? I think these curves clearly point out we are on a trajectory that without some alteration is going to drive a substantial change in the overall quality of life, both of the individuals who suffer, but I would argue more importantly about the individuals who are going to have to compete for scarce healthcare dollars, because these conditions are going to drive diseases that are going to be with individuals for a long time and increase the burden of cost. Somehow we have to figure out a way to get a bend on this curve. While Nir's working on the back end of trying to improve health span, I would argue that one of the things we need to join with is also improving the quality of life for younger individuals by addressing this excess condition of over obesity. So the next slide shows the overlap of how we view these things. Energy metabolism, we believe, is associated with, or the dysregulation of energy is associated with a number of overlapping diseases: obesity, hypertension, excess fat in the liver, called non-alcoholic fatty liver disease, elevated glucose, which ultimately leads to diabetes, and dyslipidemia. And taken together, these are a disease state that's far broader than the single cause and effect I mentioned earlier. It is true we have drugs to treat hypertension, but it's also true that a very large number of them simply do not measure up over time. In fact, many individuals who show early signs of response to a hypertensive agent or antihypertensive agent, eventually they wind up having to take a second and a third. And what I would argue is that the underlying comorbidity of dysfunctionality or dysregulation in the energy system contributes to the waning effect of those agents. The same is true with dyslipidemia. We've addressed cholesterol and circulating lipids, but combinations of the other conditions with diabetes and NAFLD and now obesity, I think, argue that we need a different approach, one that is far more oriented around trying to address the integrated problems associated with this. Next slide, please. So we have seen improved outcomes in hypertension with the result from treatment decisions based on risk, whether it's blood pressure, cardiovascular disease, obesity, et cetera, versus disease-specific thresholds, blood pressure alone. So to Nir's comment about the integrated view of you can come with a disease and you're probably going to get another one, we need to think about how the regulatory process can be changed so that we can effectively develop an acceptable approval path for improvement of health span, regardless of the point where an individual enters, whether they have no disease or several diseases, and so that the quality of life that we could contribute, this is different than treating a single underlying disease. And the regulatory process is cumbersome at best, but it's almost impossible to navigate through unless you are treating a disease. And it's very difficult to argue that treating a condition that may lead to a disease the agency has taken the position, for instance, that showing that you reduce the rate of becoming a diabetic when you have a cohort of subjects that are pre-diabetic, reducing the rate that people become diabetic is not an approvable endpoint. But back to Nir's comments, I would argue we need to have a fresh thought about the possibility of opening up an approval path that improves the quality of life, which very well may be a measurement of delay of comorbid onset conditions. No one will argue that it isn't better to stop the decay from prediabetes into diabetes, but it's just not in the regulatory process yet. And this is clearly where the expertise in this room and on the call with Hogan Lovells and others can help us move through this. Why do I emphasize this? Go to the next slide. Like Nir mentioned, the odds ratios are enhanced when you have one disease moving to another. And these are simply the ratios of if you already have a stroke, you're more likely to have diabetes. If you have diabetes, you're more likely to have heart disease. If you have heart disease, you're more likely to have a stroke, and vice versa. The arrows run both ways. None of these are below zero, or below one. So you would think that with this kind of information, there would be a clear and compelling demand that we treat this dysregulation of energy because it's implicated, back to my blue flower diagram, it's implicated in many of these. Go to the next slide. Because diabetes is a disease and approvable endpoints, thanks to the NIH study that showed that glycosylated hemoglobin, HbA1c, was a goal, an approvable endpoint to modulate. Diabetes today, of the 28 million people with diabetes, approximately 22 or 23 are actually on medication. The 96 million people who are obese, a tiny portion are on medication. Well, why is that? You would think that the understanding of diabetes, the role of obesity in leading to diabetes, would have facilitated a much higher use of medicines. Well, part of the problem has been that the treatment methods that have been approached in the past have really been, they carried a heavy weight with regard to safety issues. In many of the drugs, the number needed to treat is 4 to 5 to get a benefit. The number needed to harm is 4 to 6. So that's not a very wide therapeutic index. The second thing is we have become a society of instant gratification. We want a pill that enables us to live and do our life whatever we want to be. And my expectations is if the pill doesn't immediately result in weight loss in the next week, it isn't working. We even see that in TV ads where they say, lose weight fast, ask me how. Lose 30 pounds in 30 days. Lose 3 inches off your waist in 2 weeks. I can argue with you that there's very little evidence to suggest that's a fundamental change in the mass of the body. It's just other ways are achieving that. But more importantly, we don't have a clear understanding in the insurance community of the reimbursement, and physicians are afraid to treat some of this. Yes? Was there a question?
Go ahead, Joe.
All right, these and other factors have contributed to, quite frankly, very disappointing results. And I would argue we need a new model. Next slide, please. We can't sustain the track we're on. Current tools are not working it, they're underutilized, and they're not producing better results. And I would argue that there are a number of reasons why, and they integrate back to a need for a different view of the condition of life, the quality of life. What God has created and given us is an opportunity to live a full life, but we somehow have not defined that full life in the definitional terms necessary to get people to be motivated to do something about it. Next slide. Patient compliance less than 65%. This is across all disease states. It's even less in obesity. Unfortunately, clinical trial designs often produce results that are not going to be replicated in the clinical practice setting. Compliance is one way, but oftentimes you find promotional considerations focus on results from a single approach. I think a more a problematic situation is obesity is viewed as a condition not worthy of worry. Similar to diabetes, it's often left untreated until comorbidities can't be ignored. And I would argue until symptoms are experienced by the patient, primarily because we have treated the patient as a passive receiver. We go to the doctor tells us why we don't feel good. We take that as a definition of our condition, and then we are given a prescription or a treatment plan, and we go away and we are the recipient of it. But in most cases, the condition of obesity is not owned by the patient, certainly not to the same extent that if the physician says you have cancer, all kinds of community support and individual family support gets pulled into play, and we start doing research to find out what we can do and how we can change our life. Next slide. This passive receiver, I argue, is a creating of a lack of ownership, and it does not demand the barriers to receiving proper care be removed. The coordination in the healthcare system is not there. There's no reference or no easy way for the physician to integrate with the payer networks into a exercise program or a dietary consulting. It's not a serious disease. It's a high cost of treatment. But underlying all of this, I think, is that we have more of a sedentary lifestyle today. We don't have activities of daily living that burn calories, and we have excessive portion sizes coupled with other cues to drive eating behaviors, all of which I think contribute to the long-term problem. Now, are people simply sitting by and accepting this? No, I would argue they're actually engaged. We just haven't found the way to bring them fully into the mix. Next slide. We did a fairly comprehensive study to find out how do people view obesity. And you can see across the color fan there, starting on the left with unsupervised diet and exercise all the way over to surgical procedures, there are at least 7 or 8 major categories of activities or approaches that people are involved. Those on the left have increased personal accountability. Those on the right increase medical involvement. I would argue that we cannot address the impending tsunami that maybe is already on us without substantially increasing the personal accountability argument. It is becoming a part of modern marketing in the pharmaceutical industry to engage the patient as an owner. And I would argue that in the condition of obesity, which is part of the metabesity problem because excess or energy dysregulation or excess energy is so pervasive in the overlay of other diseases and the increased risk of comorbidity, we have to find a way to engage individuals. To do that, I think we have to find a way to convince both the regulatory authorities and the healthcare system, reimbursement system, that treating this is an appropriate and meaningful thing that we should do, and it is not a stigma, but an opportunity to improve health span and the quality of life. Next slide, please. As I mentioned, TV ads are showing a shift from passive, if you have this, go ask your doctor, to ownership. And I think it's working. Cost-effective solutions that focus on the consumer, I believe, can change the paradigm. One of the difficulties we have is the excessively complex system of drug price reimbursement and coverage. There are so many multiple players in the equation. I know of no market that has the 3 legs to the stool. The person who consumes the product is different than the person who prescribes it, is different than the person who pays for it. Those 3 forces are in tension and oftentimes do not overlay on top of each other. So next slide, please. So I want to run an ad that's currently running on TV to demonstrate this point about ownership. The problem is psoriasis. People don't like to be seen as a state of disease, and of course with psoriasis you do. And what is clear in the statements is people want to be clear and they want it to last, and they found something that works and keeps on working. So run this TV ad. I think it'll emphasize the point. Well, I don't think we have audio.
Joe, why don't you describe the video as your...
I'll just have to do it. They played earlier. That's interesting. Well, what it shows are individuals, including Cyndi Lauper and others, who had stood up and said that it was tough getting out there on the stage live. They didn't want to be seen as having a disease, but they took ownership when they found that Cosentyx would work. And it's an example of how pharmaceutical companies, whether it's with irritable bowel or pain or headaches or psoriasis, I think we're seeing a shift to consumer ownership. And I think one of the benefits of that is going to be a change in the profile. But we also need to be thinking about cost-efficient ways of giving people tools. Not everybody can afford Cosentyx. Not everybody can afford weight loss agents that are so expensive. Next slide. The side effects I've already mentioned. Lifestyle worries and work habits interfere with some parts of the colored fan. It's hard to manage through the system today. I mentioned that. Cost there's no question this is a barrier, and it's disproportionately penalizes people who are economically disadvantaged. Insurers promote wellness, but they've really been unsuccessful in shifting responsibilities to patients. And I think part of that is they ask the question, why? So the longevity dividend that Nir talked about, I think could be a very important component of discussion with the paying systems. I copied this quote from a patient who was interviewed in our obesity study. If I do not feel bad, why go to the extra effort if it only modifies my symptoms and not the underlying disease? And that's how they view obesity. Obesity is seen as a problem that is not solvable. And by the way, I enjoy eating and food's cheap, and the extra size of French fries or whatever is almost too attractive to pass up. Next slide. I believe that we need to start thinking about a holistic approach, a total approach, which has a combination of weight loss strategies to complement each other. That's what we're working on at NewCert. We think we have a solution, one of many, that involves the development of products that might be able to reach individuals, but it should be viewed as a part of a program. But my argument that I wanted to amplify today is it's only appropriate if there is a more concerted effort across many fronts to address the quality of life and this whole issue of health span, for which I would argue both obesity and many of its comorbidities plays a major role. And if we address this properly with the kind of motivation that we've seen to eliminate or reduce smoking or wear seat belts or have mammograms, I mean, we've done things that show we can motivate people to do things because there is a concerted message by all that it really matters. We have not addressed obesity and its comorbid conditions in this way, and I think it plays directly into this whole question of lifespan. Next page. At NewCert, we're repurposing existing agents. We think that is a easy path forward. They're well understood. They have established safety profiles, and in two phase 2 trials, we demonstrated clear efficacy in both reducing obesity and reducing other comorbid conditions. We have observed in many cases that the primary effect appears to be even more pronounced on individuals who already have some signs of some degree of insulin resistance. The way these mechanisms work is basically shifting an important sensing mechanism called NAD at the cellular level, which diverts energy away from storage in fat cells and into putting the energy more in skeletal muscle, as well as increasing fatty acid oxidation. So it's simply shifting the body's normal mechanism to reflect what would be the condition under a caloric restricted lifestyle. It's a very high probability that it's caused primarily because of the addition of leucine, which is a commonly available amino acid, that's creating a more enhanced environment for these existing agents of metformin and sildenafil to do their work. But more importantly, we need to figure out how to do this in the context of changing patient expectations. Next slide. So we think the next trial that we will run will focus on insulin-resistant subjects. It will include some diet and exercise guidelines, and we will include in there some aspects that would help measure the same secondary endpoints that Nir is talking about on his same trial design to examine any expected benefit on aging from reducing obesity that we might see. Next slide. I think it's only possible to build in a consumer-first orientation when we have relatively safe and well-understood components, because otherwise you're dealing with side effects that require really a high level of medical intervention to ensure that safety is not compromised in order to get the treatment. But it also depends on consumer activation. And importantly, I think, and this is not because of any lack of respect for physicians, it places the physicians in a secondary role behind the consumer. And I would argue that one way that builds ownership is to having consumers directly pay for their medicines. Well, that means that the costs have to be appropriate. And that's what I think we are trying to do. Next slide. We need to move from fee-for-service to outcomes. If patient pays, they will become more of an owner. We need to figure out a way to reduce drug development costs so we can lower the cost of medicines. One way might be, with your help and others, to allow conditional approval to allow real-world experience. In other words, take medicines, repurpose them, or other medicines that are relatively safe, and expect a conditional approval to increase substantially the number of observations that we could then form real opinions on. Did it work over the 2 or 3 years of conditional approval? And over that time, by the way, we would easily be able to measure some changes in the incidence of comorbid conditions. I think we need to figure out a way to get system-based incentives for obesity coverage by insurance plans, just as we've taken other diseases. And I'm not a big fan of mandating specific control at the federal level, but I think incentives are clearly opportunistic and we can create ownership improvement with using them. I believe relying heavily on clinical experience in the marketplace is the best way to assess usefulness, and the only way to practically do that is to allow safe medicines to be used by the largest population possible. It's more like a real-world clinical trial experience, and we gain so much more from that than just the continued ability to have the medicine available. We gain insights into what other modes and methods of changing and improving the risk of patients suffering. We can change many of those things as well. Last slide. I hope I've made a case that we shouldn't let the size of this problem stop us. I think real-world solutions exist. I think we can materially change the quality of life, but they're going to require coordinated changes across all aspects, and many of them are going to involve some opening of the regulatory process, but most importantly, I think, is increasing the ownership and the responsibility at the patient level. Thank you.
Thank you so much, Joe and Nir. You have given us much food for thought, non-caloric food, but I think we don't want to do is stand in the way of discussion. Let me just say very quickly that you've observed 2 important legs of the solution. That is, on the one hand, providing scientific evidence, and the other is providing a commercial model, a regulatory framework, and so forth. But these are only some of the considerations. We haven't covered a lot of them. Ethics, economics, we've only touched on. But I hope that you will, as a firm, recognize your role, your opportunity to be involved in the kind of changes that need to be made. And these can be small, fairly early mincing steps, but ultimately it can get us to the kind of incentives and change in our systems that will make it possible to make a big dent in the problem that we're facing. So without further ado, we'd like to throw the floor open for a discussion. And Dave, please do come up.
So, Catalina, please unmute the lines. Anyone? Question? Okay. And anyone in the room? We'll start the conversation. Michael?
This is so ambitious in terms of the public health care outcomes you're targeting. Can you do it without fundamentally changing our treatment path? And I'm thinking of the mass exercise where the increase, dramatic increase in a dramatic increase in obesity and diabetes. Are you finding the same sort of those sort of large food nutrition outcomes? Or influencing?
Well, I think it's a great point to remind us that pills and even digital health apps are not the solution alone. It's going to take a multifaceted approach, and it does start with what we eat. And we've made some inroads into nutritional education and awareness in our society, but we haven't gone far enough. And ultimately, these are the fundamentals. It's better to have a clean water supply than to have effective antibiotics to treat infectious disease. Or it leverages more when you start with the basics. And nutrition is first and foremost a basic, and we've got to be able to address that as part of a target within the general topic of metabesity.
Speaking of the water supply, so should we put metformin in the water supply?
Well, you know, I was involved in approving metformin. It is a favorite child of mine, and it's a long story, but it wasn't easy to get it approved. And it will be difficult to get it into the water supply. But many people believe it should be there. A number of Nir's colleagues in the aging biology arena are taking metformin without, I would say, a lot of evidence that it will make a difference. But already people are taking metformin for off-label purposes, and not even just to prevent diabetes, but for other reasons.
No?
Can you repeat the questions, please?
Well, I'll repeat it.
Thank you.
How does it relate to the discussion of anti-aging?
Young blood. Right.
So the question from Helen Trilling from our healthcare group is, one, could you talk just a little bit more about the mechanism of action behind metformin and whether, I think we'll probably get some follow-up materials.
And that's, yeah.
And why don't you start with that?
Well, I think Nir is even better qualified to address the specifics of the question, but I think we do start with a lot of basic research that shows that the needle is moved in important ways. Nir has outlined some of the evidence, but it's quite abundant. Importantly, we actually have clinical outcome data that Nir reviewed, which suggests that metformin used in a wider population can help to prevent some of these chronic complications. But Nir, I wonder if you could expand on that.
You know, Zan, when you were busy approving metformin, I worked then at Yale with Ralph DeFronza and was the first to describe the mechanism of action of metformin in humans, which is really to increase the hepatic insulin action in the liver. That's it was mechanism in diabetes. Little did I know in 1988 that metformin has a whole different perspective. Now, I showed you really fast a slide with a lot of things on the mechanism of action And I did it on purpose because I didn't want to ignore it, but I didn't want you to ask me this question because if I get you through it now, it'll bore everyone and it'll take the rest of the discussion. You're welcome to look at this slide and call me if you need any more help.
Yeah, we can make the deck available to you. Yeah.
Helen, your other question is about telomerases? And, yeah.
Nir, question about telomeres and metformin. Any connection there?
Yes, yes, there's some connection, but let me tell you that the geroscientists, we don't think that telomeres have a major role in aging. And certainly it's not a target because if you increase telomerase, in order to increase telomerase length, you're likely to get cancer. The animal models will get cancers. Cancers have the longest telomeres. In human, and you can measure your telomere in a commercial way. There's no predictive value in that whatsoever. But the people who have the longest telomeres have a 20%, 30% increased chances of developing cancer. And those with the shortest telomere have 20, 30 chances of increasing cardiovascular disease. So it's best to have just somewhere in the middle. Nevertheless, there's some claims that metformin increased telomeres length.
Just to hark back to one of the slides that Nir showed, in the geroscience community, they're working on 7 or 8 different pillars, senescence and stem cells and so forth. Just to differentiate the metabesity movement, there are basic scientists who are out there looking to find out whether they can extend human lifespan to 3 centuries or 3 millennia. Wonderful. The people are out there doing that research. We're looking at where the rubber meets the road today. We're talking about compounds that we can put into clinical trials now that might have the prospect of extending human health span by a couple of years, could be worth $7 trillion over 50 years, according to one economic analysis. And based on Nir's research with supercentenarians, a decade or more. That's something that we can achieve in this century.
Mike Druckmann?
Hi, that was a great presentation, really fascinating. You mentioned the need for FDA to recognize different indications. I'd like to hear a little bit more about what regulatory changes would help you, whether it's recognizing different endpoints or a change, for example, in the patient-reported outcome framework. That would be helpful for us to understand, I think.
Dave, I think that's your number. You could start with that.
Well, everyone hears from me too much around there. So, but let me put another point on it. As a former reviewer, so Zan sat in the role at FDA of being the final sign-off on the clinical sufficiency of a data set and approved some of the major drugs that we all depend on today. And so you would have looked at a proposed label. And the FDA culturally is so conditioned to look at disease-specific targets. And in fact, it was until 2018 that all oncology was looked at as organ-specific. Now we have tissue-agnostic oncology, but it took us all the way till 2018 to get to that. So as a reviewer, how would you have wrapped your regulatory mind around the idea of something as amorphous as health span?
Well, I can honestly say that if Nir came to me back when I was there, I would be very compelled by the idea of the self-evident value of improving the composite of disease-related complications. That would have been no problem for me. Now, the lawyers, Dave Fox, he may have come in later and said, well, we don't do that. And that, I think, is getting at the question that there does need to be, if not a change in specific regulations or administrative procedures, there needs to be a change in the mindset I would certainly agree to that.
Well, and going back to
Zan, can I add
Sure.
something here? It was really interesting when we came to the FDA with a composite. We had in the composite diabetes. And by the way, I'm a diabetologist. Okay, I still see once a week patients with diabetes. And they were fine with the composite, but they said, no, you have to take diabetes out. And I said, why? They said, because, diabetes is a chemical diagnosis, and only after 10 years, 40% of the people get complications. So it's, for us, it's not like having a heart attack, having cancer. So we actually had to recalculate. We thought of 2,700 people. We did our statistics again and came with 3,000 people and took diabetes out. Of course, we'll monitor diabetes, but it's just interesting. And of course, when we went to the NIH with a grant for that, they said, well, what about diabetes? And they couldn't care less if the FDA wants it or not, right? They wanted that. So it's kind of interesting how you find your way with these regulatory problems.
And following up on that, and going back to first principles of FDA regulatory law, I mean, we at the agency would need to see a statistically significant difference in a clinically meaningful endpoint. And maybe talk about the challenges of doing that with endpoints like this, where you really need to follow patients for many years and would need a large number of patients to show separation. And so the more things you put into the constellation, it exponentially increases the study size because you have now a lot more variability in your patient population. And that's, I think, it may not be that there's something a priori wrong with the endpoint as a matter of science or regulation. It's just that the challenges it brings to fit that into the basic regulatory framework.
Yeah. Well, and Joe alluded to this. It's very challenging to show an effect on a constellation of endpoints over a longer period of time. And that's why we do need incentives that will allow will attract the kind of investments that are needed. We also need ways to get these products out earlier, again, as Joe mentioned, so that we do get real-world experience. And I'm not talking about uncontrolled studies necessarily. We can now do well-controlled trials in the clinical setting using the technology we have today. This is a way we can get readouts by looking at literally 100,000 patients with a per subject cost that's very small, so that study ultimately doesn't cost any more than what we're now doing to approve cardiovascular or diabetes drugs using a 5,000-person trial. So that it's going to take a combination of things. First and foremost, FDA making it much more clear what the regulatory pathways can be, indications that can be sought, and what it will take to get them approved. And then that's just the starting point. We need to be able to make these products available and used and ultimately be effective in the population. Going back to everything that Joe said, it's not sufficient just to have a pill or a digital app that may do the job in a controlled trial setting. We need to have products that actually work in the real world.
If I may add a layperson's rant, perhaps, we were talking about this before the webcast. You know, it's perfectly understandable how the FDA is looking at disease-specific approaches and asking for clinically beneficial endpoints for that. But that's kind of a 16th to 19th century view of disease. And now that we're in the 20th and 21st century, we're better understanding the underlying biology of disease. And Dave just mentioned the fact that it took until last year, but now cancer is less of a tissue-specific disease and a molecular disease. So I think history is on the side of looking at the underlying mechanisms behind diseases and trying to figure out how to bring those insights to benefit patients. And I have no doubt that in the 24th century, Star Trek generation will have that kind of an approach to medicine. The question is, how do we get from here to there? One approach Zan mentioned was to see whether we can just actually access a large number of people through real-world data, et cetera. And another scientific, technical perspective would be looking for ways to find surrogate markers. And in fact, Nir, maybe you can speak to the fact that you're measuring various things so that we can validate for the agency that you can look at something that's a marker that's shorter than disease incidence or progression to disease over 10 years for 100,000 people. So there are different dimensions along which we can work toward that end.
Steve?
Quick question. And I think you've sort of talked about this a little bit, but I wonder if you could talk about maybe just a little bit more. And it's a question of not so much disease endpoints, but the endpoints in terms of length of your life, morbidity versus healthier longer. And I bring it up for me in the context of pet food. We've had discussions with CVM, and FDA generally, in that context, has been very relatively open to the notion that you can have a pet, although I'm much more interested in your view of humans, live healthier longer, and partly based on the nature of the study that was at issue. But when you talk about extending lifetime, the agency there was just no way that claim could ever be approved. Now that's sort of here nor there. But I was curious from a scientific standpoint, and like I said, you touched on it a little bit, but if you could talk a little bit more, as you're designing these clinical trials, what do you see as both the most meaningful endpoints in terms of measurement, in terms of healthier longer versus total lifetime? And then what do you think is most realistic in terms of getting measurable results that would pass the reviewer's test?
This is such a great question, and Nir addressed it earlier, but just to emphasize, in effect, the beauty of the trial he's proposing is that, in essence, it doesn't matter what the second age-related complication you prevent is, it's a value. And that really, I think, expresses an actionable endpoint for FDA. I think you're exactly right. If we just prolong survival, that's going to be a two-edged sword. There'll be all kinds of ethical considerations and concerns. What we do want to emphasize is health span. That is the period that is disease-free and can be accepted by everybody, from ethicists to scientists, as being self-evidently valuable. I think we've come to the point.
Can I just say something here?
Sure, Nir.
You know, the FDA has indication for sarcopenia, okay? I think they set us up. Sarcopenia is very end stage, okay? You can delay a lot of aging when you're 65, but sarcopenia, frailty, is very late, and they set us up for failure. I'm not saying that they set up on purpose, but this is the wrong indication. We have to find a way to avoid the sarcopenia, to avoid frailty, and that's if you intervene before, and that's what we're trying to do. So I'm just saying, when you said the FDA is not open, well, the FDA is open to those crazy indications.
So, well, crazy indications may be their specialty. This is Phil Katz. Thank you all for joining us. It may be easier to extend life than to extend the time for this program, because I'm being signaled that the plug is about to be pulled. So let me very quickly, thank you all for coming. Thank you for participating. I want to thank Nir and Joe and Thomas and Zan and Dave really for the thought that has gone into this. You know, as you get older, you learn your strengths, and you also learn those things that are not your strengths. And one of the things that's not my strength, quite honestly, is to be a visionary. And what we've had this morning, I think, is actually a number of visionary people talking about paradigm shifting, talking very audaciously about things that are not yet but can be accomplished with hard work and careful thought and, importantly, coordination. Because we're talking about the medical community, the patient community, the regulator community, the public health community, the insurance community, the economics, whether it's how much it costs to develop the drug, how much it costs to pay for the drug. I mean, clearly, in today's environment, another huge, expensive drug is not going to be looked upon favorably, which is one of the reasons we might be returning to the times when Dave was starting us by talking about what was happening 20 years ago. We may be back to drugs that work in a large cohort for a relatively small expense. But that's just one piece of all of these things that have to be coordinated and approached collaboratively. And what's exciting to me, and those of you who know me know that I'm a cynic, and so the fact that I'm excited about something is noteworthy. What's exciting to me is the possibility of this. When we first talked about this months and months ago, my concern was that this was pie in the sky, that this was, oh, this is long lives, just like Helen was asking, how is this different from that? And what I think we've heard from the 5 folks who are presenting this morning is that it's not pie in the sky, it's audacious, but it's something that if we approach it in a very methodical way, just might work. And we at Hogan Lovells are uniquely positioned to participate in this, right? Whether it's the FDA regulatory expertise, the HHS and CMS regulatory expertise, whether it's the notion of convincing FDA how to do this within their current legal framework or regulatory framework, or convincing them how to adopt and adapt, or convincing Congress to change to allow these things, or to change the laws to create incentives, as you were talking in the beginning. All of those things play into our strengths and our areas of expertise. And I think it's a really exciting possibility. And so one of the reasons that we invited so many of you to come to this is to hope that you might find this infectious enthusiasm and help us work on this in a collaborative way, because that's the only way that it's going to succeed. So let me thank you guys again for your efforts to date and for what I know will be the energy going forward. And thank you, Nir and Joe and Dave. And I hope this is the first of a number of conversations we have on the topic. Thanks.
Thank you.
Yeah, thank you. Bye-bye.
Okay.